All right, hello, math fans. All right, this is our last chapter here, and it's radicals. Okay, so just to give you a little thought about radicals, radicals were invented in 1869, and they were invented in California. All right, and that's kind of where, you know how they say, radical dude. That's where they came from. That's why it's radicals. No, actually, I'm just kidding. We're going to erase this. Radicals were not invented in California, though it sounds pretty good. All right, so a couple of things we're going to talk about with radicals. First of all, we got to talk about perfect squares. Okay, you really need to know these because it's just important when we try to simplify radicals. Okay, so if I say, let's look at perfect squares. Square root of 1 is 1. The next one, square root of 4 is 2. So basically what we're doing, if I just say 2 squared, that's 4. 3 squared, that's 9. So square root of 9 is 3. 4 squared is 16. So we got square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. Square root of 100 is 10. Now, you know, we can keep going. Though you always have your calculator to figure things out. But, you know, it's good to know a couple of them. Square root of 121 is 11. Square root of 144 is 12. Square root of 169 is 13. Square root of 196 is 14. And we can keep going on and on and on and on. All right? But it's important to understand the perfect squares. So, I'm going to show you two different ways to do this, though the one way is going to be the best way to look at it. Okay? Okay, let's start out with an example here. If I have the square root of 8, okay, what I can do is I can write that as 4 times 2. And the deal is you're looking for numbers that you can multiply to give you 8, where you can actually see perfect squares inside, where the numbers are perfect squares. So, right, I have a perfect square here. So what I'm going to do is, if I break this up, what is the square root of 4? It's 2. So I can actually take that outside the radical, and what do I have left over? I have a 2 left over. That 2 I can't do anything with, so that stays in the inside. This I took the square root of 4, which is 2. That's why I have 2 square root of 2. Okay, so here's another example. The square root of 12. Okay, well that's the same thing as saying 3 times 4. And what's the square? That's a perfect square. What's the square root of 4? Is 2. So that can come on the outside of the radical. So the 2's on the outside, and what's left over on the inside? 3. And that's an equivalent. So this is called simplifying a radical expression. Okay, so it's simplifying radicals. All right, pretty mellow. Okay, so let's kind of keep going here. If I have like the square root of 18, well, you could do 6 times 3. Okay, and that's not bad, and I'll show you how to deal with that in a second. But what I want you to think, outside the box a little bit. Okay, I want you guys to think perfect squares that give you 18. Well, isn't that 9 times 2? Right? 9 times 2 is 18. So what's the square root of 9? 3. What do I have left over? 2. So square root of 18 is 3 root 2. All right? The square root of 50. Okay, again, think perfect squares. So think of numbers that go into it that are like 4 divisible by 4, divisible by 9. And the thing is, I don't even, like this is 2 squared. This is 3 squared. Yeah, I have 4 squared of 16, but if 4 doesn't go into it, 16 won't go into it either because 4 goes into 16. So 5 squared is 25. So you're looking for numbers that go into 50. Well, again, I could say 5 times 10, but that's not thinking outside the box. Thinking outside the box is going, oh, 25 times 2. What's the square root of 25? 5. What's left over? 2. And that's your answer. Okay? Not too bad. What about the square root of 20? Well, I know, again, I could do 2 times 10, but I know, oh, let's see, 4. That's my first perfect square that comes to mind. 4 times 5. All right. 4 times 5, so it's 2 root 5. All right? It's not too bad. So, you know, numbers can get bigger. I could do the square root of 200. And again, you should say, oh, 100 is a perfect square. 2 times 100. What's the square root of 100? 10. What's the square? I can't do anything with the 2, so that's left over. Okay? Let's try something a little bit more difficult. If I have the square root of 32. Now, let's say you did 8 times 4, which is okay. Okay, you should say, oh, well, okay, I can take out that 4, so I have 2 root 8. Now, this is the deal. You guys should recognize that square root of 8, I can simplify that a little bit more. Because isn't 8 4 times 2? So I can actually take out another 2, and this is all multiplication math fans. So it's really, if I take another 2 out, I already have a 2 there, and then this 2 is left over inside there. Well, again, I told you this is all multiplication, so it's 2 times 2 is 4 root 2, and that's your final answer. Now, if you were good, you would have said, I'm looking for always the biggest perfect square. Okay, not only the perfect square, but the biggest. And the reason is because if I did 32, if I was good, I would say, oh, that's 2 times 16 is 32. What's the square root of 16? 4. What's left over? 2. So I actually got the same answer as doing it, taking a little bit longer. But it's not bad, you know, if you didn't see it right away, as long as you can keep taking something out to simplify it, that's what I want you to do. Always look to see if you can keep simplifying it. Okay, so let's see. The square root of 90. Again, what number is the biggest number? What two numbers would give you 90? There's a ton of numbers, but a perfect square is 9 times 10. 9 is a perfect square. So I got 3 that you pull on the outside. The square root of 9 is 3, and 10 left over. Okay? I hope that makes sense to everybody. Okay, and I can do this one, square root of 125. All right? You should kind of know that, gee, 25, 25, 20, right? 25 goes into that. And I don't care if you use your calculator. In fact, I encourage you guys, so do 125 divided by 25. And that gives you 5. So really, you have 25 times 5. Break it up in your calculator, and then the square root of 25 is 5. What do you have left over? 5. So it's 5 root 5. Okay? And so what you want to do is, again, it's kind of practicing with your calculator. I mean, I can give you, I'm just going to give you, I'm making one up right now on my calculator. Okay? And it's the square root of 207. And you're like, well, geez, I have no idea what goes into 207. Well, this is what I want you to do. I want you to think of perfect squares that go into 207. Use your calculator to divide it out. So you're going to say 207. Do you need to do 4? I certainly don't need to check 4. And the reason I don't need to check 4, math fans, that's a 7 there. Okay? It's an odd number. I know I don't need 4 because it's not going to work. So the next one I want to try, right, 2 squared, I want to try the next one, 3 squared. I want to try 9. So 207 divided by 9. So if I do 207, my calculator, divided by 9, ha! It works. So it's 9 times 23. What's the square root of 9? 3. What do you got left over? 23. So that's how you do it. 9 square root of 23. Okay? Let's try another one here. The square root of 2597. Okay? Well, I know I'm not going to put a I'm not going to divide a 4 into it, but I'll divide it by 9. 2597 divided by 9. Okay, that's like 288.5555, blah, blah, blah. So as soon as you have a decimal, that's not going to work. Okay? And this is the deal. The numbers I'm going to try, I'm going to try 4. And then I'm going to try 9. And again, I don't need to try 16 because if 4 doesn't work, 16 is not going to work. Then I'm going to try 25 and 36. Again, I don't need to try 36 because if 4 doesn't work, 36 isn't going to work either. And so that's 6 squared. And then I'm going to try 49. That's 7 squared. 8 squared is 64. If 4 doesn't work, 64 is not going to work. And then I'm going to try 9 squared is 81. Well, I don't need to try that either because if 9 doesn't work, 81 isn't going to work. And 10 squared is 100. If 25 doesn't work, 100 is not going to work. So this is the deal, math fans. You really have to try the 4, the 9, the 25, and the 49. Obviously, you could try 121, right? That's 11. So if something gets really nasty, though we're not going to have anything too brutal, you probably don't even have to try 121. So I would say 4, 9, 25, and 49 are probably the numbers you're going to divide by. So going back to this problem here, I'm going to divide that by the next one, which, well, I know it's not 25, because in order to be 25, doesn't it have to be divisible by 5? Same with the 4. Doesn't it have to be divisible by at least 2? So I know if it's not an odd, if it's an odd number, it can't be divisible by 4. Okay, and if it's not, doesn't have a 5 in it or a 0, if it's not divisible by 5, it can't be 25 either. So the next thing I'm going to try is 49. So 2597 divided by 49. 53. Beautiful. So 49 times 53. What's the square root of 49? 7. What do I have left over? 53. That's your answer. Okay? So you're always looking for perfect squares that go into it, and then you'll break it up after that. All right. So I can also give you a problem like this. This is a little more challenging. The square root of 2940. Well, I'm going to start out with 4 because it's an even number. And if I do 2940 divided by 4, I get 735. That's good. And, well, so this is what I have. I have 4 times 735. I need to check that 735 and see if I can break that down. If there are no perfect squares that go into it, then you're done, except you just have 2 root 735. So it's 735. What am I going to divide it by? I have your choice of 4, I have your choice of 9, 25, 49, and that's it, right? I said the four values to plug in there. I know it can't be 4 anymore. I can try 9. 735 divided by 9. Nope, 81.667. Not good. I know it's not 25 because this is 35 here. That either needs to be a 25, a 50, a 75, or 100 in order to divide it by 25. So that's not good either. Well, let's try divide 735 divided by 49. And very good. So when I divide by 49, I get 15. So truly, this problem is 4 times 49 times 15. Do you guys agree? 2940 breaks up to 4 times 49 times 15. So this is the deal. Again, it's all multiplication. The square root of 4 is 2, so the 2 comes on the outside. The square root of 49 is 7. That comes on the outside. And I have 15 left over. So that stays under the radical. And again, it's all multiplication. So 2 times 7 is 14, root 15. And that's your answer. Okay, so I can give you just a brutal problem. In fact, I'm going to do that. All right, I'm going to make it up right now. Let's see. Look at this, man. Brutal. The square root of 749,700. Okay? So right away, I look at this problem, and I could, again, a little shortcut. I know 100 goes into that because it's 700. So I can divide this by 100. So I really have 7497 times 100. Okay? And now I want to see if I can break that up. Well, I can't do a 4. So remember, I have 4, 9, 25, and 49. Those are my numbers to check. 4 doesn't work. Let's do 9. 7497 divided by 9. Yep. So it's if I divide that by 9, I get 833. Okay, so it's 833 times 9 times 100. All right, and then I'm going to do 833. Again, you keep going until you know you don't have anything. Well, again, I know 4 is not going to work there. I'm going to try 9 again. Okay, nope, that doesn't work. Well, so that's out of there. 25 is out of there. Let's divide 833 divided by 49. Look at that, man. That works. So this number, if I divide it by 49, I get 17. So I can write that whole problem out as 17 times 49 times 9 times 100. Okay, that's what that number is broken up to, and that's using my calculator. So this is the deal. 17 stays in the radical, but the square root of 49 is 7. The square root of 9 is 3. The square root of 100 is 10, and I have 17 left over. So I multiply all this together. 7 times 3 is 21, times 10 is 210. So 210 square root of 17. Okay, and that's your answer. It looks complicated, but if you do it the way I'm showing you, life is easy. 4, 9, 25, and 49, man. Those are the numbers you want to start dividing into and see if it works out. Now, granted, I divided by 100 right away, so that just kind of worked out. But, guys, think about it. Isn't 4 times 25 100? So if I took a little bit longer and I divided it by 4 first and then by 25, that would have given me the same answer. Okay, but I recognize 100 is easy to recognize. Okay? All right, so those are perfect squares. Let's talk about a couple things that where people make mistakes. If I say what's the square root of 16, okay, that is just 4. And what happens, this is a mistake. So this is a common error that people make. They take the square root of 16 and they leave the square root over the 4. And they say, oh, well, that's the square root of 4 is just 2. Or they leave the square root of that. I mean, you guys, if it's a perfect square, the square root is gone. Okay, square root of 25 is just 5. If there's something left over, like the square root of 20, which we've done already, which is 4 times 5, and I have 2 root 5, that's still left over in there. So it's got the 5 there. But if it's a perfect square, square root of 36, it's just 6. There's no radical left over. So if it's a perfect square, you get rid of the radical. It's really important. All right, a couple of common mistakes here where people don't simplify it enough. They leave the square root of 8. I'm going to list the square roots that people leave. They leave the square root of 8. They leave the square root of 1. They leave the square root of 12. They leave the square root of 18. And sometimes the square root of 20. Okay, these are all common mistakes that I've seen in the past that kids leave as they don't simplify it enough. Okay, you guys have to know that 8 is 4 times 2. What's the square root of 4? 2, and a 2 left over. This is really a silly common mistake, but people leave a square root of 1 there. Why would you ever leave a square root of 1? The square root of 1 is 1. Okay, there's no square root around it. That's the easiest one to simplify, so don't leave the square root of 1. Okay, square root of 12, 4 times 3. Okay, they're common mistakes because 4 is a small number and people don't really think about it. But if a 4 goes into it, I can take something out of it. So in this one, the 4 comes out, and I have 2 root 3. Okay, the square root of 18, that's a common mistake. 9 times 2. The square root of 9 is 3. That comes out, and I have a 2 left over. Square root of 20, 4 times 5. Square root of 4 is 2 root 5. So don't make these mistakes, guys. Don't leave a radical that needs to be simplified underneath there. If you're not sure, start dividing by 4, start dividing by 9, start dividing by 49, oh, and 25. Okay? Start dividing by those values and see if you can pull something else out. All right? I got a couple more things to show you here. One is if I have a number in front already. Let's say I have 6 square root of 20. Well, remember, guys, it's all multiplication. Got to remember that. So that 6 is just hanging on the outside, and I'm simplifying the square root of 20. Well, isn't the square root of 20 equal to 4 times 5? So it's 6 times 4 times 5, radical 4 times 5, and I'm going to pull this out. So again, it's all multiplication, so it's 6 times square root of 4 is 2, and you got a 5 left over. So 6 times 2 is 12 root 5, and that's your answer. Okay, so that is, don't get confused by it. If there's a number on the outside, that just means you're going to multiply that number, that after you take out the radical, you're going to multiply it by that number. So if I give you 8 times the square root of 27. Okay, well, square root of 27, remember, 27 is 9 times 3, perfect square. Square root of 9 is 3, so 8 times 3, you got a 3 left over, so 8 times 3 is 24, square root of 3. Okay, not too bad. Let's try 5 root 98. Okay, 98. Not sure. I'm going to do 98 divided by 4. 98 divided by 4. Nope, 24.5. Okay, so, well, 25, 9 doesn't go into it. I know that because it's not 99. And 25, let's try 49. 98 divided by 49. Ah, look at that, 2. So it's 5 times 49 times 2. And square root of 49 is 7. And you have a 2 left over, so it's 35 root 2. Okay? That's not too bad, math fans, right? Okay, well, before I end this lesson, I showed you perfect squares, pulling perfect squares out. I also want to show you another way, which my first few years teaching this, that's the way I show the kids how to do it, and then I decided they got to do perfect squares. It's much easier. If you have a pair of numbers, that's equal to a perfect square. So in other words, if I have the square root of, let's just say the square root of 18, that's equal to, and I'm going to break it up and do as simple as I can. So 18, isn't that 2 times 3 times 3? Okay, these are all prime numbers. Okay, and a prime number means you can't break it up any more than that, because 2 times 3 is 6 times 3 is 9. Okay, so this is another way of looking at it. If I have a pair of 3s, so 2 3s. If I have 2 3s, when I pull it out, I just have one of those, because right, it's like saying the square root of 9 is 3. So 3 root 2. So if you have a pair, you basically pull out pairs. Okay, which is the same thing as pulling out a perfect square. So if I gave you something like this, 17 times 17 times 3. Let's say it's all broken up for you like that. I would look at this and say, oh, I got a pair of 17s. So 17 comes out, and I got 3 left over. Okay? So a pair of numbers is the same thing as a perfect square. I don't necessarily want you to do it that way, because I would rather you look at that 8, like this problem right here. I'd rather you look at that and say, oh, 9 goes into that. It's 2 times 9. So it's square root of 9 is 3, and you got a 2 left over. I'd rather you look at it that way, but later on you're going to have numbers where maybe you may have a pair of numbers, and you should just recognize right away, as opposed to multiplying it together, just take it out because it's a perfect square. Okay? So just remember, a pair of numbers is the same thing as a perfect square. All right? That's it, math fans. I hope you learned a little bit about radicals. This is a very radical and gnarly lesson. Have a good day. Goodbye.